Hello again, everyone, and welcome back to the Turf Equipment Maintenance Facility here at the Atlanta Athletic Club. Today I'm talking about relief grinding, and I wanted to start off with just talking about my opinions behind relief grinding, why I relief grind, and just lay that out. My primary purpose for relief grinding is friction reduction. Reducing the amount of wear caused by the reel blade passing by the bed knife. And whether you're running contact or no contact or heavy contact, light contact, relief grinding is a benefit. And I've proven it to myself by running experiments, spin grind only versus a relief grind, the effects on wear on the bed knife, and it's just really a dramatic improvement in bed knife life when you relief grind the reels. So that's why I do it. I'm not lapping reels here at this facility. I've never really lapped reels in my career. I've been fortunate enough to have grinding equipment available. And it was always my philosophy that, you know, if I'm going to take the time to lap a reel, I might as well tear it down and grind it, because especially with these grinders, the process is so fast that the benefit just isn't there. When you relief grind a reel, it does form a valley on the back side of the reel blade to hold your lapping compound if you are lapping reels. So that, I guess that would be a benefit if you are lapping reels, but I really advise against it, because when you lap a reel, you contour the top face of the bed knife to match the radius of the reel and take away much of that top relief angle that is such a benefit for evacuation after the cut. So it can be a down and dirty for people out there who don't have grinding equipment, trying to get by in between a contract grind or whatnot. But if you have grinders, especially if you have Peerless grinders, it just doesn't make any sense to lap reels. So I'm going to get into just, I've thought a little bit about how to present the setup for relief grinding, and that it is more involved than a spin grind, but it really doesn't take any more time. But I've thought about how to demonstrate, how to illustrate the setup without having a reel in the way. So I'm going to reset the camera here, and we'll start looking at the grinding head and the changeover from spin grinding to relief grinding. We'll go through the indexing mechanism, setting up the indexing mechanism properly, and then we'll actually finish up with getting a cutting unit up on the grinder and showing the setup start to finish. Okay, so now I have you looking over my right shoulder, and we've got the spin grinding wheel on here right now, and I'm just going to remove that off of the shaft and set it aside. The fit between the hub and the shaft is only about 1/2 of an inch, so whenever we're installing a new hub on the shaft, we want to make sure we run a rag through that and take out any chips or anything, grinding swarf, dust that might be in there. This is the grinding wheel that we use exclusively here in the shop for relief grinding. It's a ceramic wheel. The grinding grit is a ceramic material, and it is designed to be very aggressive and actually be sacrificial, so that the ceramic material, as it abrades off of the stone and the stone wears down in diameter, we're always exposing fresh cutting angles. It's not like a lot of the aluminum oxide wheels will, the grinding media itself will, the corners of it will round off. The ceramic material is always fracturing and presenting fresh, sharp teeth to cut the material that you're grinding. So it really is aggressive. When we install the wheel, push it all the way in against the snap ring and go ahead and snug it down. We don't have to go crazy with torquing these wheels on here, just a good snug fit. And then our indexing mechanism has 2 captive screws that will mount right down onto the mounting tang. We snug up one, and then we snug up the other before we tighten the first one. And that ensures that it's sitting nice and parallel to the grinding wheel. And that's your basic changeover. It only takes a few seconds to do. It takes a lot longer to talk about it. Now I'm going to talk about the indexing mechanism itself and what we're looking for in terms of general configuration. So this is the indexing mechanism for the relief grind, and here on the right side of the indexer we have the 2 mounting screws, and they're captive screws. They won't come out of there, and they're also countersunk so that as they're tightened down, they align the whole assembly to be parallel to the grinding wheel. Down below here we have the 1 button head screw that connects the rest of the indexing mechanism to this mounting bracket. And this is great because you can see here the indexer actually has a milled track in it that keeps it parallel to the mounting bracket. And as your grinding wheel wears down, all you need to do is loosen up this 1 screw and slide the whole assembly down relative to the bracket and maintain a close fit between the guide pin and the top of the grinding wheel. Here on the other side of the indexer we have the stop pin arm, which moves back and forth and catches that reel blade, that next reel blade as it comes up, and of course it has the spring that pops it off of the end of the reel blade as it completes a pass. The stop pin itself is held with this 1 screw, and we never really adjust that after we get it installed at the right height. We want the stop pin to be, the top of the stop pin to be relatively even with the top of the guide finger, I call it the guide finger. I think the instruction book calls it the reel blade guide or some such, but I call this the guide finger because it's bent like a finger would be and slides across the reel blade. Adjustments, you've got the 2 screws that retain the guide finger, and 2 screws are used because there's a fair amount of torque on this guide when it's coming off of the end of the reel blade, and you've got the torque of the drive clutch trying to turn that blade, and it's actually trying to twist this at the end of every pass. So two screws are used here to retain that, that guide pin. On the other side, we've got the screw with a spring on it, and that spring just keeps the screw from backing out or changing adjustment due to vibration. Because on the end of this screw, all it's doing is adjusting the position of this stop pin. When we catch a reel blade, as the reel blade comes around and it comes down, it should be sitting flat on that guide finger, and there should be just a little bit of play in between that stop pin and the guide finger when the reel blade is resting up flat on that guide finger. Next to the screw with the spring on it, we have another adjustment, and this adjustment adjusts how far that stop pin will flop back as it pops off of the end of the reel blade. And we want enough of a gap to be able to run the reel blade through there with plenty of clearance, but we don't want it to pop off so far that the next reel blade coming around misses the top of it. So depending on how many blades you have in your reel, you may adjust that up a little bit or back a little bit. I've found over time that leaving the adjustment in the middle of the slot is really adequate for almost all the reels that we are grinding here in our shop. And that's really it as far as the indexer mechanism goes. I'm going to go ahead and remount it, and then we'll talk a little bit more about the geometry and how everything interacts there with the indexer. I have the indexer mechanism remounted on the mounting bracket, and I've adjusted the guide pin here, the guide finger, to be very close to the grinding wheel but not touching the grinding wheel. I like to keep about a 10 to 20 thousandths air gap there when I adjust it, and then I'll readjust it after the wheel wears down enough that I have a 1/16 to 3/32 of an inch of an air gap there. I just keep an eye on it every few reels. I'll look at it, and if I feel like I need to snug it up a little bit, I just reach around back, and that one button head cap screw, loosen that up, and I can slide the whole mechanism down, and that keeps all the geometry consistent between the stop pin and the guide pin. And you'll notice that on the first setup, I'll have the guide finger have just a little bit more clearance so that I've got room to rotate this if I need to. Reels are wound with different helix angles depending on manufacturer and depending on a lot of times blade count. I know, for example, the new Toro Edge reels have less of a helix angle than the older model Toro reels, so you may need to adjust that, and that's those two screws that are closest to the grinding wheel. Of course, we hold the reel blade up against the grinding wheel, and we rotate the whole mechanism around, and then pinch the blade and the guide together. If we've got too much of a gap like that, we'll rotate the pin around so that it fits flush with the blade, and likewise, if it's hitting on the tip, we'll bring the finger back a little bit so that you want that finger to ride flush against the reel blade as it's sliding along. If it isn't setting parallel and you reach the end of a pass, you could wind up over grinding the end of your reel as the blade falls off that angle a little bit and rides down. Our stop pin is adjusted so that when we have the reel blade riding up flat against the guide, that's the screw with the spring on it, we'll bring our screw in until we just feel it bottom out, and if we're holding our reel blade, we can feel it bump up against the reel blade. Then I back off about 1/4 of a turn, and we just want that little bit of clearance there in between the stop pin and the reel blade. Those are the basic setups for the indexer mechanism. The whole indexer mechanism is held to the grinding head with this band clamp, and if we back off that band clamp, we can rotate this whole assembly around the grinding head axis. And when I do the first setup, I just rotate the whole assembly back and around so that it's not in the way of anything when I'm setting up my grinding wheel to the reel blades. So now I'm going to move the camera around the other side, and we'll have a look at the relationship between the reel blades and the grinding wheel. Here I'm using a pair of scissors to represent the reel blades, and depending on whether or not you've got a large diameter reel with only 7 or 8 blades, that would mean you'd have a large distance in between those reel blades. Or you could have a 14 or 15 blade 5-inch reel where you have hardly any room in between those reel blades. So setting your grind angle is really dependent on the reel diameter, and I've always just used the factory grind angles and run a Sharpie across a couple of blades and bring my grinding wheel up until I match the scratch of the existing grind angle. If I'm hitting too far towards the tip, I know I need to bring the wheel up so that grind angle then starts to lay back a little bit. Remember, we're grinding the rear blade, and the front blade needs to have an air gap here, so we don't grind off the fresh ground edge on the blade. But a lot of it will depend. I've had a lot of people asking me, well, how, you go up till you bottom out on the 2 reel blades, how far do you go down? And there's too many variables there. It depends on how worn your grinding wheel is, because the more worn it is, the higher it will go, the smaller radius you've got, and the higher it'll go, and that changes your starting point and so on. How many reel blades do you have? Do you have a 7-inch 8-bladed reel where you've got just a mile in between the reel blades, or are you dealing with an 11 blade, a 14 blade, 15 blade reel? So a lot of that really just depends on how worn your reel is, how worn your stone is. So I always like to just match up my factory grind angle here, and I'll just take a Sharpie and run down one of the blades and then give it a scratch, come off of the end, rotate that reel around and have a look at my scratch pattern on that reel blade. And if I'm down too far towards the tip, I know I need to raise that grinding wheel up so that I effectively rock that blade back a little bit, and just back and forth. It only takes a few times before you see the cause and effect of raising or lowering that reel or grinding wheel rather, relative to your reel blade, and you can dial it in pretty quick. Once that position is set on the grinding wheel, we leave the grinding wheel in that position, and we'll rotate the indexing mechanism up and around, and then back underneath the reel we'll hold that back blade on the top of the stone and rotate the indexing mechanism so that the guide finger, the blade guide, rests up against the blade at the same time that the blade is resting against the stone. We pinch all three of those together, and then we lock down our clamp that holds the indexer mechanism in position. And that position won't change for that whole series of cutting units. If you're doing all John Deere 7-inch 10-blade reels, the position of this indexer is not going to move. We're just going to keep putting cutting units on top and grinding. The only thing that'll have to move, like I said before, is as this wheel wears down, we'll have to lower that mechanism down, but raising and lowering the mechanism doesn't change the geometry of the setup. We've got the center line of the reel on top of the center line of the wheel, and so that whole relationship doesn't change as the unit is lowered down, because it's lowering down vertically, and so that's that basic setup of the grind angle itself. And now we'll go ahead and we'll mount a reel up on the grinder, and I'll show you the rest of the setup with setting up our traverse stops and our spin clutch. Here I've got one of our QA7 cutting units up on the grinder, and it's already been through the relief grinding process. I really don't have any reels right now that have not been through the freshening process, getting ready for season. But I figured we could use this as a good example for matching up the existing grind angle. I've marked several of the blades here with a magic marker to make the scratch more visible, and now we'll bring the stone underneath and bring it up into contact with the reel blade, turn the stone by hand while gently holding the reel blade against the stone, and we'll see where we go from there from a scratch pattern. Here's the view from the leading end of the cutting unit. You can see that I've moved the grinding wheel up under the reel in the area where I've marked that reel blade, and I kind of eyeballed the angle to start with, just brought it up so that it looked kind of even. Now I will hold the reel blade gently against the wheel and just spin it by hand, and then we'll come back around to the front side and have a look at the scratch pattern. That's all it takes, and we'll gently bring the stone back so that I can turn the reel blade around and have a look at the scratch pattern. Well, here's my initial scratch pattern, and you can see I'm just a little bit down towards the cutting edge on this blade. So if that's the case, then I know I need to raise my grinding wheel a little bit so that I get more coverage all the way across that face. So in this case, I'm going to raise my grinding wheel about 20 thousandths and take another scratch test, and we'll see how that looks. Here's a scratch pattern that I got after that 20 thousandths move, and you can see now I'm a little bit too far towards the back side of the blade. So I'm going to drop down about 10 thousandths, and we should be about on the money. And that did it. We've got a nice even scratch across the surface of the existing grind angle. And what I'll do now is set my indicator wheel to 0 without moving my grinding wheel position. And this will be my starting position for my relief grind. At this point, what I'll do is bring the grinding wheel back underneath the reel and hold the reel blade up against the wheel and bring my guide finger on my indexer up to just rest against that blade so that all three are making contact at the same time. Here I have the camera position, so we're looking down through the reel, and I'm holding the blade up against the grinding wheel, and I'll rotate the indexer mechanism and hold the guide finger so that it's touching the reel blade as the reel blade is resting on the grinding wheel. From here I can lock down the indexer and it'll be set for the rest of the grind. Well, okay, it's actually been a couple of days since I set the grind angle on this cutting unit. Finally able to get back on the video project here. The next step in the process is to make sure that we have even contact on the grinding wheel from leading to trailing. And you would think that since we spun ground this reel to a true cylinder before we started the relief grinding process, that we would automatically have even contact on our relief grinding wheel, but that's not always the case, because the twist of the individual reel blades isn't always consistent when they assemble the reel and clamp the reel blades to the spiders before they weld all the reel blades in. Those blades may have a variation in how they're sitting in those slots in the spiders, and the twist of the individual reel blades might be a little inconsistent. On these John Deere QA7s, the 10-bladed reels, I really haven't seen much of a variation. But some reels you will get one. You just need to pay attention on your setup. Don't take it for granted, I guess is what I'm trying to say. So we'll go back and forth pretty much just like setting up for a spin grind. Bring the grinding wheel up until it just barely contacts a blade. Double check that we're on 0. Come down to the other end and go through the same process. And when I'm moving the grinding head from end to end on the reel, going back and forth, it's important to keep the reel twisted up against the guide finger. Keep that reel blade in contact with the guide finger. If you don't do that, of course, you come down to one end and then the grinding wheel will contact your freshly ground edge, and we don't want that. So what I do, since you can't run the machine with the cover open, I hang a nice big 1/2-inch drive ratchet off of my reel drive, and that acts as a counterweight so that when I move from one end to the other, it keeps that reel twisted back against the guide finger. Of course, before we really get too much into the process, we want to double check that that stop pin is not resting too tightly up against the reel blade. The first pass across, I'll adjust this screw with the spring on it, and I'll just gently bring it up to touch. Use a light touch on the driver, and you can feel when that screw just makes contact with the stop pin arm, and then once it does, I back off about 1/4 of a turn. That way I know that the reel blade is laying up against that guide finger. It's not being held off of the guide finger by the stop pin at all. I've got just a little bit of clearance there. Now I'll start with the leading end, and I'll infeed the wheel until I just get a light scratch. I'll double check that I'm on 0. I'm off by just a couple of thousandths there. I'll back off the wheel, come down to the trailing end, and repeat the process. And I just got a light scratch, and I'm less than 5 thousandths off, so I'll call that good. This being an adjustable reel type of cutting unit, if I was off, I could just use a wrench and adjust the reel up and down. If this was a fixed reel type of cutting unit, then I would go around back and adjust my fence post, my adjustable fence post on the trailing end, forward or back, to get more or less contact on that reel blade. The adjustable fence post is usually screwed up tight against the stop pin, and in that position it's zeroed out and parallel to the grinding axis. But you can take that stop pin out and adjust the screw forward and back and move that post forward and back, and that will either give you more or less contact on that end of the reel. So once we get our contact even, now it's time to set up our traverse stops. We want the leading end hard stop on the traverse to be set so that when the grinding head comes over and contacts that hard stop, there's a full engagement with that reel blade against the stop pin, but there's plenty of clearance in between the end of the reel and the indexer mechanism itself. The trailing end traverse stop is not nearly as critical as the leading end. We just don't want the stop pin to run into the side frame. We want the grinding wheel to travel over as far as we can, but it's not absolutely critical that the grinding wheel make it all the way off of the end of the reel blade. On each end of the grinder, we have 2 sets of stops. We have the hard stop on top, and then we have the reversing stop down below. And what we'll do is we'll hold the grinding head up against that hard stop, and then we'll shift the reverser rod and slide the stop over against the stop there, so that when it hits the hard stop, it will trigger the reversal. The leading end traverse stops are the same as the trailing end, but the instructions call for only setting the hard stop and letting the pressure rise trip the reversal on the leading end. And this gives time for the reel to index. From my practical experience, I've been able to run both sides with the reversal. Now that I'm comfortable with the machine, I've ground many reels on the machine, and it's much faster to engage the reverser instead of waiting on every pass for that pressure rise to trip the reversal. Now, the final step in setting up the relief grind is setting up the spin clutch. When we spin grind, we lock the spin shaft solid to the drive with the inner collar, and for relief grinding, we run the reel drive through the spin clutch. And this has an adjustable amount of drag. By turning this knurled ring, we can adjust how much drag we have on the clutch and how much torque we apply to the reel. That's kind of a balance. The more torque that we twist on that reel, the harder it's going to hold that reel blade down against the grinding wheel, and the more aggressive we can be with the grind. You can play with it and see if you do get a little bit of chatter as the grinding wheel goes across. You can try increasing the clutch tension a little bit. but generally speaking, you don't have to be that aggressive with it because the grinding wheel itself is so aggressive. So there we have the machine set up, ready to go. Our grinding angle is set. Our contact is set from leading to trailing. Traverse stops are set. Spin clutch is set. And we're ready to run. Now, just for demonstration purposes, I have bypassed the safety switch on this machine so that we can run it with the door open. I do not condone bypassing safety switches, but just for demonstration purposes, I wanted to be able to show all the operation of the machine. So the first thing that we do is we'll start up the spin, and I have the spin speed set down to around 100 RPM, and we'll have a look at the spin clutch operating here. You can see that it's just barely rolling over, and I can check the tension on the clutch, and you can see how it's returning back against that stop pin. That looks good, so I'll start up the grinding wheel. And now I'll start up the traverse. And you can see that we're just barely tickling the reel here. I'm even going to back off a little bit so you can hear me. If you notice the traverse speed on the machine, when we move from the leading end to the trailing end of the reel is when we're doing almost all of our cutting. And the traverse speed is still a little faster than your spin speed would be, but then the return speed is much faster because we're really not doing much cutting on the return back from trailing to leading. So the reel indexes, and now we start another cut. Moving around to this end, you can see the stop pin pop off of the end of the reel, and then the head will traverse back. We index another blade, and we start on another pass. Stop pin pops off, and we head back to grab another blade. We'll walk around to the other end, and we'll show the indexing down here. Down. You notice the little notch that I've cut out of the side frame of this QA7 makes room for the indexer pin, the guide finger itself. Now we'll give her a little infeed. Now that you're relief grinding and everything looks nice and even, you can go ahead and in-feed. If you're starting off with a reel that you know that you got to take a lot off of, you can in-feed up to 50 thousandths at a shot, no problem. That ceramic wheel is going to take the material off very quickly. Like I said, if you do get any little bit of chatter out of it, you may back off your in-feed a little bit or tighten up your spin clutch a little bit. Sneak up on your land width that you're looking for. You may only in-feed 15 or 10 thousandths towards the end of the grind, but once you get all of the reel blades ground the way you want, then you can just stop at the end of a pass, disconnect your spin, lower your grinding head, and pull the cutting unit off of the machine. Now, subsequent setups are super simple because none of your geometry changes as long as it's a like kind cutting unit. The next one goes up and you align the leading end of the reel with the indexer mechanism when the grinding head's held up against that hard stop, and then you bump it back and forth a little bit until you get right on the sweet spot, lock it down, hook up your spin, bring up your grinding head, and all of that geometry doesn't change. I do double check that clearance between the guide finger and the wheel after every couple of three reels. Just get in the habit of looking at that gap every time you pull a reel off, because it's real easy to make that adjustment when a reel's off of the table. And then keep an eye on your land width leading to trailing, and make any adjustments as needed. You can make those adjustments on the fly if you need to during the grind from the back side of the machine. Just stop your traverse, go around behind the machine, make your adjustment, and continue on. So change out should be really under 5 minutes for your setup for your cutting unit, and then of course your overall relief grind. It's going to depend on how much material you're taking off of those reel blades. But typically on a maintenance grind, we can turn one around in around 10 minutes or so. But that's really it when it comes to changing out from cutting unit to cutting unit. Well, that pretty much does it for the relief grinding process here at the Atlanta Athletic Club. Sorry it took so long to produce this video. Had a lot going on with the golf industry show out in San Antonio, and then getting caught up when I got back. I wanted to touch on the grind angle, and what do you do if you are starting off with a reel that just has no relief on it whatsoever? How do you handle that? Well, you can bottom out the wheel in between two reel blades gently, of course, and then count down from there, either a half a turn, a whole turn, 1.5 turns, whatever that is, depending on basically how it looks. And then you can get a angle finder from Home Depot. I got I think it's like $6. This comes as a parallelogram style, and I just knocked 2 rivets out, and that leaves me with this leg that you can lay on the front side of the reel blade, and then lay the bottom of the scale on the ground angle that you have. And when I do that here, I'm getting right at 60 degrees, which pretty much matches up with what we're getting out of the John Deere factory. And I know, the grind angle itself really isn't critical to quality of cut. Now I know I'll get a little bit of backlash from that, but within reason. Let's put that qualifier in there. You could be up around 75 degrees all the way down to 45 degrees on your relief grind angle. Setting that up around 75, 80 degrees, you're going to still get the benefit of a relief grind, but you're going to have to refresh that relief grind more often. And conversely, if you go all the way to like 45 degrees, you're not going to have to refresh that relief grind as often, but you're going to be on the grinder for a long time because you've got a lot more material to remove in that case. So I think 60 degrees is a good compromise in between those two extremes. And when we relief grind, we go all the way. Again, my philosophy is if we're here, we might as well take it all the way down to where we've got about 30 thousandths land width. That way we won't be back here nearly as often. So these reel blades are starting off 3/16 of an inch thick. 187 is what they check out at, and I'm taking them all the way down to 30 thousandths on the land width there, and we have excellent results with that at 60 degree relief. The strength is reduced a little bit in the very tip of that reel blade, which can be a benefit, especially on a fairway unit, because if it does hit something, the damage tends to be more localized. If you aren't running relief, or you're not running a lot of relief in that reel blade, you have a lot more meat in that reel blade, and if you do hit something, it tends to transfer the damage all the way through the reel. Whereas if you've got that edge taken away, the backside of that blade taken away, if you do hit something, it tends to be localized into a small area of the reel blade. So that pretty much covers this video. Next up, I think I'm going to be getting on to the surface plate and looking at reel geometry and how different adjustments affect reel geometry. Hope you like what you saw. If so, please like and subscribe. Click that little bell icon so you get a notification when the next video comes out. And thanks for watching.